Alright, so welcome to the second video. This video is going to be about precipitates and ions. The problem says the following. Aqueous phosphate ions form a precipitate with silver ions according to the following equation. And it gives the equation. Then it says 41.18 centimeters cubed of a solution of aqueous silver ions with a concentration of 0.2040 moles per decimeters cubed is added to an excess of phosphate ions. The questions to be answered are A. Calculating the amount in moles of silver ions used in the reaction. B. Calculating the amount in moles of the precipitate silver phosphate formed. And C. Calculate the mass in grams of that same precipitate. So for part A, we need to use one of the most basic formulas in chemistry, which is moles equals concentration times volume. The question is asking for amount of silver ions. Now, we have that a solution of aqueous silver ions has been added, and we have data on that aqueous solution that has been added. We know its volume, we know its concentration as well. So we can easily just plug those two values into the equation and solve for moles. The only thing to note would be that when you put the values into standardized units, now concentration is already in moles per decimeters cubed, so there's no need to change that, but the volume is in centimeters cubed, so that 41.18 must be divided by 1000 to be in decimeters cubed before multiplying in order to get the moles of silver ions. But once you do that, you just multiply the concentration by that volume divided by 1000, and you get that the moles of silver ions used in the reaction is 8.401 times 10 to the negative third. Now part B asks us to calculate in moles the amount in moles of the precipitate of silver phosphate that is formed. For this, when you look at the equation and the ratios that it provides, we know that the molar ratio of silver to silver phosphate is 3:1, as we can see in the equation that 3 moles of silver ions are reacting and 1 mole of silver phosphate is being produced. Now, taking into account this relationship, we're able to know that the amount of silver phosphate, which is the amount that we want, is equal to the amount of silver ions divided by 3. Now, we already have that amount of silver ions from the previous exercise. It's 8.401 times 10 to the negative third. So we just need to divide that number by 3 to get the moles of the precipitate of silver phosphate that is formed. If we do that, we obtain that the amount of moles of silver phosphate is 2.8 times 10 to the negative third. Now part C asks for the mass of that precipitate. Now it's not in moles, now they want it in grams. So the first part of this exercise is to find the molecular mass of the precipitate, right? So we know that the precipitate is silver phosphate, and we know that this is its formula. So when you multiply 3, the subscript of silver, times the molecular mass of silver, which is 107.87, then when you multiply 1, which is a subscript of phosphorus, times its molecular mass, which is 30.98, and then when you multiply 4, which is a subscript of oxygen, times the molecular mass of oxygen, which is 16, and then we need to add all of that. So doing that operation, we obtain that the molecular mass of the precipitate is 418.58 grams per mole. Now, leaving that aside, we know that mass is equal to molecular mass times the amount. And why is this? Because we are canceling the units. Molecular mass is given in grams per mole, and amount is given in moles. The moles divide with the moles and just cancel, and by dimensional analysis, this just yields grams, which is exactly what we want. So the way to go forward is to multiply this molecular mass of the precipitate we have just obtained times the amount in moles of the precipitate that we obtained in the previous exercise. We do that, we get that the mass of the precipitative silver phosphate that is formed is 1.172 grams. So that would be it for this video. I hope you understand how to get precipitates, amounts, and masses, some other transformations in units and in terms of dimensional analysis. I hope the video was useful, and again, you have the presentation in the description as a link. So thank you.